Hello, Assalamualaikum warahmatullahi wabarakatuh, and salam sejahtera to every one of you. Okay, so in this video, we are still at solving second order non-homogeneous linear differential equation with constant coefficient. So let's have a look at this example in which the fx contains of trigonometry function. Okay, so the question is, you need to solve y double prime plus y equal to 2 sine x using method of undetermined coefficient. Okay, so in the question, you are not given with the initial condition, so it means that you need to find the general solution to this ODE. Okay, so let's go through step by step. Okay, step number 1. You need to find the YC for the corresponding homogeneous equation. So from here, the ODE given is a non-homogeneous. So the corresponding homogeneous equation is equal to y double prime plus y equal to 0. So remember, when the fx is 0, we call it as a homogeneous equation. But when the fx is not 0, so it is non-homogeneous. Okay, so from here, based on this, you come up with the characteristic equation for the quadratic. So m squared plus 1 is equal to 0. Okay, so 1 you move to this side, so it becomes negative 1. So m squared equal to negative 1. So m is equal to plus minus square root negative 1. Square root negative 1 is equal to I. Okay, so your m now is plus minus I. Okay, so from here, it refers to the case number 3, whereby your alpha is 0 and your beta is 1. So for case number 3, the solution for the homogeneous equation is yx equal to exponential alpha x multiplied with a cos beta x plus b sin beta x. Okay, so in this case, the alpha is 0, the beta is 1. So now your yc is equal to exponential 0 because alpha is 0. A cos beta is 1, so become a cos x plus b sin x. Okay, so this is your yc. Okay, so exponential 0, you can simplify it become 1. So your yc is now a cos x plus b sin x. Okay, now once you got your yc, you can go to step number 2 to find your yp based on the fx. Okay, so now your fx is 2 sine x. Okay, you refer to the table that I provided in the part 1. Okay, so this is the trigonometric case, so it belongs to type 3. Okay, so if your fx is equal to k sine nx, so you assume your yp is equal to c cos nx plus d sine nx. So in this case, your n is equal to 1. Right, so that's why your yp is c cos x plus d sine x. Okay, now you need to compare your yp to the yc. Okay, let's have a look. So c cos x have the same pattern with a cos x. D sin x have the same pattern with b sin x. So your yp we consider as a same as yc because it has same pattern as yc. Okay, so what you need to do, you need to multiply your yp with x. So your new yp is cx cos x plus dx sin x. Okay, so and then now you need to check it back. You need to compare it back with the yc. Okay, so now none of these terms have a same pattern with yc. So at this level, your yp is considered not same as yc. So you may stop. So based on this yp, this is your latest yp, you need to do the differentiation 2 times. So you need to get yp prime and yp double prime. Okay, so now you have yp is equal to cx cos x plus dx sin x. Okay, so we differentiate yp in order to get yp prime. So we differentiate cx cos x, we differentiate cx, we got c cos x plus, we differentiate cos x, we got negative sin x. Okay, and then dx sin x, we differentiate dx, we got d sin x, and we differentiate sin x, we got cos x. So you have dx cos x. Okay, So after that, we rearrange it accordingly to cos x and sin x. So for cos x, I have c plus dx, and then for sin x, I got d minus cx. Okay, so this is my yp prime. So next, I differentiate it again to get yp double prime. So again, I differentiate cos x, I got negative sin x, and I differentiate c plus dx, I got d only. So here, I differentiate sin x, I got cos x, and I differentiate d minus cx, I got negative c. So we rearrange it back to cos and sin. So cos x, I have d minus cx plus d. So d plus d, you got 2d. So 2d minus cx cos x. And then for sin x, here, I have negative c plus dx minus c. So what I got? Negative 2c minus dx. Okay, so this is my yp double prime. So next, we need to substitute the yp double prime and yp prime into the given dE. Okay, sorry, in this time, we don't have yp prime, so we just substitute yp double prime and yp into the given dE. So in the dE, yp double prime plus yp is equal to 2 sin x, and then we substitute accordingly yp double prime. This is yp double prime plus yp equal to 2 sin x. Alright, and then after that, we need to rearrange it accordingly to its own coefficient. So I arrange to the coefficient cos x and coefficient sin x. So for cos x, 2d minus cx plus cx. Okay, so it's negative cx plus cx. I can cancel it out, so I left with 2d cos x only. So here for sin x, negative 2c minus dx plus dx. So dx minus dx and plus dx, I can cancel it out. So left with negative 2c sin x. Alright. And then I can do the after I rearrange it, I can equating the coefficient. So for cos x, so 2d is equal to 0, right? So because at this side you don't have cos x, at this side you have 2d only, because this and this can be cancelled out. So 2d equal to 0, so d equal to 0. For sin x, okay, negative 2c is equal to 2. Okay, so c is equal to negative 1. So then we substitute c and d back into the yp. So your particular integral yp is equal to yp here. Yp is cx cos x dx sin x. So my c is 0. And then d is negative 1. So I got negative x cos x. Okay. And then the final one, the general solution for the ODE is equal to y equal to yc plus yp. Okay. So my yc is equal to a cos x plus b sin x. Yp is negative x cos x. Okay, so this is your general solution to the ODE. Okay, so that's all from me. Thank you for watching.